Hello, everyone. This is Miss Calcavecchio or Miss Calc, your calculus teacher. How is everyone doing today? How are your weekends? That's great. I'm seeing a lot of thumbs up. If anybody wants to share what they did over the weekend, they can go ahead and put that in the chat now. That's great. I'm seeing a lot of people spent time outside. It's been beautiful out. I spent time outside over the weekend as well. Okay, class, we are going to get started with our lesson for today, which is on the first derivative test. Okay, class, we are going to start today with a do now problem, just like we always do. I want you guys to take out a piece of paper and a pencil and start answering that first question, which is to use the graph to identify the following: the relative and absolute minimum and maximum values of the function, and then also the intervals in which the function is increasing and decreasing. So this is a little refresher from your algebra class. You guys should remember how to do this. And then I also want you guys to start thinking about the definition of these terms in terms of slope. So this is not something you guys have seen before, but I want you guys to try your best, and we will be reviewing this later on in the lesson. Okay, class, time is up for the do now problem. No problem if you guys didn't have enough time to finish it. We are just going to go over it together as a class. So we were asked to find the absolute maximum value of the function, the absolute minimum value of the function, relative maximum values of the function, relative minimum values of the function, and then also the intervals in which the function is increasing and decreasing. Okay, can anybody raise their hand and tell me what the absolute maximum value of the function is? Okay, yes, Amanda. That's great. The absolute maximum is at 4.2. Amanda, why is this an absolute maximum? That's right, because it's the highest point on the entire function. Okay, so now the lowest point on the entire function is 2, -2. That's pretty obvious, right? 2, -2. Okay, so now we have relative maximums. Can anybody raise their hand and tell me what a relative maximum is as opposed to an absolute maximum? Yes, Theo. Okay, so you're close. So a relative maximum is a maximum on a certain snapshot of the function, right? So if we were looking at this snapshot right here, Theo, what would the maximum value be? That's great. So -1, 1. So this is a relative maximum, right? Because it's not the highest point on the entire function. It is in just this snapshot. So would the absolute maximum count as a relative maximum? Thumbs up, thumbs down. So I see a mix of both, so it does count. 4.2 is also a relative maximum because 4.2 is the maximum value on any snapshot of the function, so this still applies here. Okay, any other relative maximums? You guys can put it in the chat. Okay, great, I see 7.1, that's right. All right, are we done? Thumbs up, thumbs down? Thumbs up, that's great, we are done. These are all of the relative maximums of this function. All right, what about relative minimum values? All right, I think you guys are getting this. This is awesome. -2, 0 is 1. I also see the absolute minimum value in there at 2, -2. That's awesome, guys. Okay, and I see 6, -1 in there as well. Awesome job. Okay, so in terms of slope, all of these minimum and maximum values have what slope? Yes, Alex. So great, they either have a slope of 0, what about at this point right here? Is the slope 0 at -1, 1? So yeah, the slope here is undefined. So our maximum and minimum values will occur where the slope is 0 or undefined. Okay. So now what would the slope be for an interval where the function is increasing? Okay, great. I see in the chat some people were saying a positive slope. That is right. What are the intervals in which the function has a positive slope? Okay, yes, between 6 and 7. This is interval notation, guys, not a point on the graph. Interval notation. Okay, where else? All right, I see 2 and 4. And then also -2 and -1. Great job, guys. Okay, what about the intervals in which the function is decreasing or has a negative slope? All right, I see between -1 and 2. That's great. And then we also have between 4 and 6. And then anything else, guys? That's right, that is it. Great job, guys. All right, we're going to move on from here. Okay, class, we're just going to go over some definitions that apply to that do now that we just did. So the first one is for critical points of a function. So it says a number c in the domain of f, right, the x values of f, is called a critical point if either f prime of c, right, the slope at c, equals 0, or if f prime of c or the slope at c does not exist. So how does this apply to the do now that we just did? Yes, Alex, go ahead. Okay, that's great. Yeah, so our minimum and maximum values, right? The x values at those values will be critical points, right? So we have to keep in mind that these are only referring to our x values. However, the y values determine whether a point is a minimum or maximum value. Okay, moving on. So the next definition is for increasing intervals, right? So it says if f prime of x, right, the slope at x is greater than 0 or positive for x within the interval between a and b, then f is increasing on that interval, right? So if there's a positive slope at x within a certain interval, then f will be increasing on that interval. Okay, and then the last one says if f prime of x is less than 0, or if the slope at x is negative for x within the interval between a and b, then f is decreasing on that interval. Okay, guys, any questions? Nope, okay, great. We're going to move on from here then. Okay, class, we are finally getting to our first derivative test. So this is new information from here on out. I want you guys to all keep your attention on me during this lesson, okay? So it says, suppose that C is a critical number, not numbers, of a continuous function f, right? So going back to our definition, a critical number happens when? When the slope is, that's right, when the slope is 0 or undefined. Okay, so if f prime, right, the slope changes from positive to negative at C, then f has a local maximum at C. So I'm going to draw a little picture to kind of demonstrate what this means. So if f prime, or the slope, changes from positive to negative, so I'm going to draw a little function where the slope is positive, hits 0 at our critical point, and then goes to negative, right? It's pretty obvious after you draw this little diagram here that this is going to be a maximum value at C, right? We're going from a positive slope to a negative slope. Okay, now let's go over the next part of this test. So if f prime changes from negative to positive at our critical value c, right? So negative slope, we could hit an undefined slope. I'm going to make this one a v, right? So here we have a minimum at our critical number c. So negative slope to positive slope indicates a minimum. And then lastly, we have that if f prime does not change sign at c. So this means that either goes from a positive to a positive slope or a negative to a negative slope. So a positive to a positive slope, that would look like this, right? We're hitting 0, but besides that, our slope is staying positive and positive, but 0 at c, or undefined, but most likely 0 in this case. So here we don't have any minimum or maximum values, right? There is neither a local maximum or minimum at c. And then the same occurs if we're talking about negative slope to 0 to negative. Negative to negative. There is neither a local max or min in this case. So we have to be careful when we're doing this, right? A critical number does not necessarily mean that there's a maximum or minimum value. We could be in this last case for this test, and there might not be either. Okay, any questions on this so far? Okay, great, we're gonna move on then. Okay, class, we are going to be doing our first example on the first derivative test. So it says, find the critical points in the intervals on which the function f of x equals 5x squared plus 6x minus 4 is increasing or decreasing. Use the first derivative test to determine whether the critical points are relative maxes, mins, or neither. So we are always going to start these problems by finding our slope or our derivative. So f prime of x in this case equals 10x plus 6. We are going to be setting this equal to 0 to find our critical points and solving for x. So to solve for x, we subtract 6 from both sides. We get 10x equals negative 6, and then we divide by 10 to get that x equals, after reducing this fraction, negative 3 over 5. So there is only one critical point in this case. Okay, so our next step will be to draw a number line of our critical points. So I'm going to put my critical point here, and then I'm going to put a 0 above it to show that the slope is 0 at negative 3/5, because this number line will be indicating slope. Okay, so now we want to test values to the left and right of all of our critical values to see whether the slope is changing from positive to negative or what. So here I'm going to pick a number to the right of negative 3/5. I'm going to pick something easy because we have to plug this back into our first derivative. So I'm going to pick 0. And then for a number to the left, I'm going to pick negative 1. And now we are going to plug these values back into our first derivative. So f prime of 0 equals 10 times 0 plus 6, which equals 6. So our slope is positive to the right of negative 3/5. And now we're going to check the slope at negative 1 by plugging in negative 1 to our first derivative. 10 times negative 1 plus 6 equals negative 10 plus 6, which equals negative 4, which is obviously negative. So our slope goes from negative to positive at this critical point, negative 3/5. Can anybody raise their hand and tell me if this means that negative 3/5 is a minimum, maximum, or neither? Yes, Cindy. Great, this means that negative 3/5 is a minimum because we are going from a negative slope to a positive slope at negative 3/5. So we go from negative to positive, which means we are hitting a minimum. Okay, so the last part of this problem is identifying the intervals in which the function is increasing or decreasing. So this number line really helps us out because we already know where the function is increasing or decreasing. We know where the slope is negative and positive. So we know that the slope is negative for all x values less than negative 3/5. So in interval notation, we will write between negative infinity and negative 3/5, the function is decreasing. And then the function is increasing where the slope is positive, or for all x values greater than negative 3/5, from negative 3/5 to infinity, not including negative 3/5, because here is where the slope is 0. Okay, we are now done with our first example. Any questions? Okay, great. We're going to move on then. Okay, class. So I provided a graph of the function that we just did in example 1 to show that if we graph these functions, we can identify where the minimum and maximum values are. This is a way to check our answers. So we see that here is our minimum value, right? At x equals negative 0.6, that's the same thing as negative 3/5, like we found out in that first example. So if we're ever unsure if our answers are right, we can check on a graph. I will not be letting you guys use a calculator come the exam, so it is important to know how to find these answers without a graph. But this is a great way to check to see if we are doing these processes right. Okay, moving on. Okay, class, we're just going to answer some questions together on the material that we learned today. So, what type of function wouldn't have any critical points? What does everyone think? Yes, Maya. Okay, so Maya said a linear function. That's very good. So any linear function that has either a positive or negative slope will not have any critical points, right? Because the slope will never equal 0 or be undefined. And there will also be no mins and maxes because there are no critical points. That's great. Okay, next question. How can we use the first derivative test to sketch the graph of a function? Yes, Amanda. That's great. Yes, we can use that number line we made, right, with our critical points and the sign of the derivative to the left and the right to kind of make a little sketch, right? Negative slope to positive slope with a slope of 0 in the middle there. Okay, great. Okay, next question. Can a graph go from increasing to decreasing or vice versa without hitting a min or max? Yes, Josh. Okay, you're close. So Josh said that since we could have a critical point that's not a min or a max, that we can go from increasing to decreasing without hitting a min or a max. But actually, if we're going from negative to positive or positive to negative, right? We have to hit 0 somewhere in between here. There has to be a 0 between them. So we always do hit a min or a max when we're going from positive to negative or negative to positive. Okay, any other questions? Alrighty. Okay, everyone, I was jumping around to everyone's breakout rooms. You guys did a great job. This was kind of tricky because it wasn't exactly like the problems we've been doing in class. But we're going to go over it together as a class to see where the similarities lie. Okay, so can anybody raise their hand and tell me what the first step of this problem is? Yes, Max. That's great. Yeah, we should find the maximum values of these height equations. So we're going to start by taking the derivative. So h prime of t equals negative 32t plus 64. We're going to set it equal to 0 to find our critical points, just like we've been doing. So we have that 32t equals 64. We're going to divide by 32 to get t equals 2. And I'm going to do the same thing for the height of Walter's ball. So we get that negative 26t plus 52 equals 0. And then we're going to solve for t. So 26t equals 52. And again, we get that t equals 2. So I saw that in some groups, people said that Mary and Walter tied because they hit their maximum value at t equals 2. This actually is not correct. So at t equals 2, right, at time equals 2, the balls reach their maximum height. But we don't know what that height is. That height is going to be modeled by our y value at these points. So I like that some people noted that since this is a negative quadratic equation, right, we know that it's going to hit a maximum value, right, because it's going to be kind of like a hill-shaped graph, right? So we don't really need to do that number line test that we usually do with the first derivative test. But some people did, and that's great. If you didn't catch that, it's really important to show that you know that it's going to be a maximum. It's also kind of obvious because you wouldn't be throwing the ball down, right? They're seeing who can throw it the highest. So we're going up, and then the ball is going to come down due to gravity. Okay, so to find out who threw the highest, we have to plug these t values back into our height equation for our y values or our h values, the height of the ball. So h of 2 is going to equal negative 16 times 2 squared plus 64 times 2. This is going to equal negative 64 times 4 plus 64 times 2, which is going to be 128. And then negative 16 times 4 is 64. Negative 64 plus 128 is going to equal 64. So that is the height of Mary's ball. We are going to do the same thing with Walter's, but we're going to plug it into his height equation. So we have negative 13 times 2 squared plus 52 times 2, which equals negative 13 times 4 plus 52 times 2, which is 104. And this equals negative 52 plus 104, which equals 52. So who won? That's right, everybody, Mary won because she had the highest height for how high she threw her ball. Okay, any questions on this? All right, great job, guys. Okay, everybody, as usual, we're going to end class with an exit ticket. So I want everybody to complete this work and upload it to our course site, okay? So we are asked how many critical points does the function f of x equals x cubed minus 12x plus 1 have? Are these critical points relative maxes, mins, or neither? Explain. So use the first derivative test for this first question, okay? And then I also want you guys to name something you understood from today's class and something you did not understand, okay? This is going to be ungraded. This is just to kind of give me an understanding of how well you guys are grasping this material. Okay, class, now that everybody has uploaded their exit tickets, I just wanted to offer you guys some additional resources on this material that we learned today. So I offered links to 2 websites. One is Khan Academy and the second one is Math World. So if you guys are confused or would just like some extra practice, feel free to check these websites out. Also, please feel free to email me if you have any specific questions. We can also set up a time to meet one-on-one to discuss where you are having difficulty with this subject. Okay, class, great job today. Here is your homework assignment for you guys to do before next class. So for the first 5 problems, you're going to be doing the same thing that we've been doing with the first couple example problems. So you're going to be finding the intervals in which the function is increasing or decreasing and using the first derivative test to determine whether the critical points are maxes, mins, or neither. And then 6 and 7 are some challenge problems for you guys. Don't sweat it if you're not able to figure them out, but please give it your best shot. All right, guys, I will see you next class. Great job today, and I hope you guys have a great rest of your week. Bye, everyone.